Hey again, guys. The last example we'll do here is what if you have to find the area between curves with respect to the y-axis. I think somebody had asked this in class, a week or so ago whenever we were doing the integration stuff, and here's where it really comes into play. So let's start with two equations. Let's go y equals x minus 1 and y squared equals 2x plus 6. All right, if we had to approach this with what we currently know, we would need to solve this, as y equals plus or minus the square root of 2x plus 6 and get a good picture and go from there. So the picture, y equals x minus 1 is basically this line. That's y equals x minus 1. And then the square root 2x plus 6, it looks like it hits at negative 3. So somewhere here, so the square root's going to come up like this. When x is 0, y is what? The square root of 6 or something silly like that. So it's basically just going to do one of these. Wherever it hits, it hits. And then it's got to be plus or minus, so it's going to hit down here too. Okay? So basically the region we're dealing with is this entire thing right here. So it's kind of tough to do this with respect to the x-axis if you think about it, because you've got this weird situation here where the top and the bottom are the plus and minus versions of the square root function up until they hit. And then when they hit, it's going to be the positive square root minus the linear equation. So that's really annoying. So what we do actually, instead of going top minus bottom with respect to the x-axis, we can go right minus left with respect to the y-axis. Okay, essentially, it's not quite like this. It's really more like this. I know you can't really see it through it. But this would be the top, you can almost see it here, top minus bottom from here to here. Okay, oops. It gets a little disorienting. But we can still do it this way. But looking at this picture the way it is, we just need to figure out what these equations are, in terms of y instead of in terms of x. So if y equals x minus 1 is y, in terms of x, y equals something with x, well then x is going to be y plus 1. Just solve for x. It's the same equation. X equals y plus 1 is right here. If you plug in a certain y value, you're going to get a particular x value. If you plug in that x value, you're going to get the same y value we had here. Okay, it's the same thing. This one, a little more annoying. This one's going to be, let's see, 2x equals y squared minus 6. So x equals 1/2 y squared minus 3. So this is x equals 1/2 y squared minus 3, and that is literally this curve. Okay? So same idea, just in terms of y instead of in terms of x. Now that's a little harder to put in your calculator. When you go to put this in your calculator, it's going to be, y equals 1/2 x squared minus 3, so it's going to be inverted. Again, you can't really take your calculator and, yeah, you can do this, but it's not really that. It's actually this. Good luck seeing the picture underneath there. Okay? So my recommendation would be to just, trust the picture. I guess you could try to draw them. What I know some people have done is they literally just type it in. They would literally just type this in as y equals 1/2 x squared and just pretend it's the x-axis because it just helps them. But technically, that's not really what it is. But whatever works for you. The bottom line is it's the same exact idea as before, but instead of doing top minus bottom, because that gets a little, can get a little complex, we're doing what essentially is the top with respect to the y-axis minus the bottom with respect to the y-axis. So it really is the same idea, but visually it's right minus left instead of top minus bottom. So my integral will be, I got to go from here to here, so I do need to figure out where those two cross, which we could do by hand, or you can do it, I guess you could do it in the calculator just to get the intersection points. Just realize you're using y values, not x values, okay? So I've done this before. I got -1, -2, and then I think this one was 5, 4. Okay, you can confirm that. You can do them algebraically. You can set them equal. Just realize we're dealing with y values, not x values. So I really want from -2 to +4 when I go to set up this integral. Okay, so this is going to be from -2 to +4, right, which is y plus 1 minus left, which is 1/2 y squared minus 3 with respect to y. Okay, so the basic idea again here is I'm going right minus left from the lower limit to the upper limit for the y values. Okay, again, if I were to, let's see if I can do this. If I turn it this way and turn it this way, I'm going top minus bottom from here to here. Okay, from here, see that? Same point, right? I do it again. Here, watch this point right here. Right here, when I go back, right there where my finger is. That's the lower limit. So I know the temptation is to just do this, right? That's the temptation. But this is actually the lower limit, so it's kind of confusing to go from here to here as low to high. It's really this way, from low to high, or from left to right. Okay? But again, I still, personally, I think this is overall the easiest way to do it. But whatever works for you visually. I know it can get a little confusing when we go this way instead. Okay, and then this becomes whatever it is. You could probably do this one by hand. You could do this in the calculator. Let's see, what was this one actually? Let me double check. This one ended up being 18. So if you want to check it out, you can check it out. What else can I say? I guess, you know what, for practice, if you want, there's nothing stopping you from doing it with the x-axis. Do this minus this from, you know, -3 to -1, and then from -1 to +5, go top minus bottom and see if you get the same thing, just for practice. I think that's a lot more work. Obviously, it takes a little longer. There's more room for careless errors, but it will get you the right answer eventually. But obviously, we want to do it the most efficient way possible. So with respect to the y-axis, can be an easier solution. You just got to kind of look for it. And if you need any help, be sure and ask. This is the last video for the main, you know, for this main idea, but I can make more. It's just we're heading out very soon. So I will be back tomorrow. So any questions, post on Edmodo, and good luck with everything. And hopefully, I would say if you can have this done by Thursday, you know, you're right on pace. I will post the other videos for the second main idea either tomorrow or Wednesday, and then that'll be due obviously for Monday. So really, it's just 2 assignments. You know, if you can get one done by the end of this week and then one done from Friday over the weekend, if you want to get them both done early, obviously that works too. But as always, any questions, post them, and I'll help you through. Okay? All right. Have a good New Year's if I don't talk to you before then, and I will see you later. Bye.